Alrighty, we are in 6.2, where we said last time with 2 places we can represent numbers up to 2 places, so 59 groups of 60 and 59 ones, or 59 left over, which would then mean 59 times 60 plus 59. And the representation in Babylonian would be tedious as it is to write a 59. I guess I have to do it. 5 tens and 9 little ones. For the first place, space, 5 tens and 9 little ones. For the second place. And that is the representation for 3,599. Now, what happens if I have one more? If I add 1, whoa, almost fell. Not really. If I add 1, what do I get? 3,600. But this guy is full. This guy is full. Where is it going to go? Now think about this. Think about our decimal numbers. If I have 99 and I add 1, 9 is the largest digit. Did it? I did something. It's the largest digit. And if I add 1, it's full. That place is full. What happens when I add? These together make 10, which then goes to the tens column. But the tens are also full. There are 9 tens. With another 10, together, I didn't think this through, make 100, which has a 3-place representation. So we need more places. Need more places when they're both full. So I'm going to have 3 places. From right to left, I'm still representing or counting the leftovers or the ones. And I'm still counting the 60s. But now I'm going to count the 3600s. Is that so strange? When you think about it for just a second. Just a second. Think decimal. Decimal counts ones, tens, hundreds, and so on, right? What is the link between a 10 and 100? Why 100? That's not random. 100 is 10 groups of 10. Or 10 times 10, 10 squared. What is the link between 60 and 3,600? 60 squared. It is the same. Well, it's not the same. It's very similar, except where we count in tens, they count in 60s. How I go to new places is still linked to the 60. All right, and I can have more places, but oh yeah, we could. Yeah. Using this to make bigger numbers is much more efficient because I'm sticking to my 60 base. Everything is still in 60s. And now this third one in from the right, third one in, is going to count the number of groups that has size, that's 60 groups of 60, because I can't fit those in anymore. So let's just do maybe exercise 6.3, the first one, which is a 3-place number. So maybe it helps you to just remember, okay, 1s, 60s, 3600s. I see 3 places very clearly, so that is what they're going to count. From right to left, left to right, I don't care. Which one is going to... What is the quantity that sits in the 3600 place? It's a 2. And then the middle one is a 52. I'll put these in brackets because that's just temporary to help me count. And then a 16, it looks like. They are small, so look carefully. So this then means that it's 2 groups of 3600 plus 52 groups of 60 plus 16 left over. You put that in your calculator, you get an answer. You're done. Just like you would have little Timmy write out 200 plus 50 plus 3. That's 2 times 2 groups of 100 plus 5 groups of 10 plus 3, and so on and so on. It's the same thing, except it's not 10s, it's 60s. What do I get for an answer? Can anyone confirm? All right. So it's in a way a very natural extension of the places to be able to handle larger numbers. That is these not multiples, powers of 60, which is where the 3600 comes in. Now you could say, just like in the case of 1,000, I'll do a new page. In the case of what comes after 100, rather, would be counting thousands. So if I have 1, 2, 3, 4 places, decimal, I would count ones, I'll say tens, then hundreds, then thousands. This is just 10. That 100 is 10 squared. That 1,000 is times another 10, 10 cubed. So these are increasing powers of 10 as the group size in the decimal numbers. We're going to do exactly the same, except we have, maybe I'll make them bigger, hold on. Except we're doing everything in 60s. Ones, 60s, 60 squared, 60 cubed, and you can keep going forever. Now we'll stop at this length of a representation, mainly 60 squared, but every now and then we'll just dip our toes into the next one to remember it's there. I don't know what 60 cubed is. Oh, I was going to say that. And you don't have to remember it either. It's simply counting the increasing groups of 60, all based on 60. So nothing's really strange. It's just the 10 that we're used to is swapped out for a 60. And then we use some fancy symbols just to make it interesting and look fancy. Yes.
Is it called a base 60 system?
It is exactly what it's called. It's based on 60s. It's called a base 60 system for obvious reasons. So if we now go to that exercise, 6.3, number 1b, we see we have 4 places. Now you can tell me for how much longer I need to do this in between one. I don't know. If it gets annoying, let me know. Left to right, right to left, I don't know, left to right. The first one, because I read left to right, I guess, is just a 1. Then the next one in is a 57. And then you say the next one. 39 and 46. Now I just put them together. One group of 60 cubed. You can write 216,000 or just 60 cubed. Your calculator can handle both. 57 groups of 60 squared. 39 groups of 60 and 46 left over. It's good to just make sure that you can do the powers of 60 in your calculator as well, just as a check, and then it's done. So see if you can calculate that. See how easy it is. See if you need to practice it. We won't know until we actually do it. If anyone has an answer, say it slowly so I can write it down and then someone can confirm it.
423,586.
All right. So you decide how well are you working with your calculator? Do you need to practice a little bit more? Totally up to you. But the more important thing, no, it's all important. You need to get a final answer. But the more important thing, if I have to pick, is to translate what that means. Get the calculation. And if you show the calculation, but you make a calculator mistake, then at least I can see, no, you did understand how this works. The C one is just 3 places. Let's just do it all in one line, because it's going to be something times 60 squared plus something times 60 plus something. So this first 43. And the 60s, 36, and the leftovers, 40. You put that in your calculator, you get a number, you're done. It's really not that complicated. Let's see what we get. Sorry, I totally wasn't listening. 157,000. All right. Very easy. Any questions on how to read the Babylonian number and convert it to the decimal quantity? We have a lot of time. The other direction, the other conversion, is usually perceived as more difficult. So please let me know. And the way I'm doing it is just my guess at what you need to make this as easy as possible. You can adapt this as you need to. You don't have to write it like this. 23,596. How the path that you take to the answer is your path. You can personalize it. This is one option if this is not easy for you. So I'm going to make a little table. I'm going to look at the specific power of 60. Then how many, or the number of groups. Then what have I used? Then what is, oops, see, that's supposed to be a pen. What is left? And that's it. So I need to know what is the largest power of 60 that can fit in there. So I do know 60. The next one is 3,600. We've learned the next one is 216,000. And that's too big, right? That's too big. So the largest power of 60 that can fit in there is 60 squared. And that's 3,600. We're not going to go past 216,000, so don't worry. It's just, if you can do the small numbers, you can do bigger ones. And then once you've decided on the biggest one that can fit, we have to go all the way down. Can't skip any once I have my starting point. So now, line for line, how many times does 3,600 go in there? If you want to do it in your head, go for it. But I think most of us would maybe use a calculator. So you simply divide it, and you get 72 point something. Oh, she said 72, sorry. Oh, what do you get? How much? 6 point something. So that means 6 whole times. Okay. So now I need to know how much have I used? Well, 6 times 3,600 is what I've used. What is 6 times 3,600? 29,600? 21. And then I see what is left. By just taking the original amount, subtracting what I've used, I need to account for what's left. It's all calculator stuff. So 23,596 minus 21,600 is 1996. I still have to fit that in somewhere. And the 60s can fit that in. How many 60s can go in there? 33. 33 times 60 is what I've used of that 1996. 33 times 60. Not that column. This column. 1980. Stop me if we're going too fast. And then I can see, as the numbers get smaller, the part that's left is easier. 16's left, and the ones will mop that up and use all 16 with nothing left. I need to get a nothing left in the end. I need to break up that 23 until nothing's left. All of its bits have to go somewhere. Either in the big 3,600 bin, or the medium 60 bin, or the leftover bin. So that means I can go up here and say that this original number can be broken up as 6 groups of 60 squared plus 33 groups of 60 plus 16 left over. And you can put that into your calculator and double check that you get 23,596. Good check. So that means that the number 23,596 in Babylonian is a 3-place number. Left to right is a 6. Space. Then a 33. Space. Then a 16. And there you go. We'll zoom out a little so we can see both.
Sorry, what was, how many, so 60, 33 goes into what? So 60 goes into what 33 times?
The leftover, the 1996.
Oh,
That's the only things I have to still take care of. After I've fit in as many 60 squares as I can, what's left needs to be mopped up by the 60 as much as I can, and then the leftovers will go in the last ones bin, if you want to think of it like that. Any other questions on this one? Maybe the most difficult one in terms of calculation and laying it out in a way that helps you get the answer. You don't have to make a table. I'm just looking for this end result. But help yourself get to the right one. Comments, thoughts, doable? This takes practice. I felt more resistance for Roman numbers than this one. Yes?
Is there a different way to do this?
That's really up to you. I need to get to this. I need to get to this splitting of the number. And over time, the table was my best effort to help you. But if you think about it in a different way that works for you, I'm going to say you can adapt it to how you need if it works. But it might confuse someone else. So see, what about the table do you not like? Everything. The amount of work is not going to change. The calculations that you have to do will essentially be the same. It's just keeping track of those calculations. That's all you need to do. The table is trying to help us keep track of the calculations. If you want to keep track of them in another way, they're still going to be there. There's no sidestepping the calculations. Yes? So say again? Maybe 6. We're not going to go past that. Yeah. Is there one with a 6? Yes, there is. The B one. There's no such thing.
I'm confused how you got to the 21 numbers in this column. Like, how do you go from the how many to the
We say,
okay.
if I have 6 groups of 3,600, that is multiplication to get 21,600. Someone said 21,600. Yeah. If I say 3,600 times 6, I get 21,600. Because 6 groups of 3,600 means multiplication. And then I do a subtraction from the original amount. And then I do the same thing with this number. You do this 5 times, it's always the same. So I would say whatever layout or way of writing you're going to use, always use the same. Always do the same thing. Whatever that may be. Always do the same thing. So you can get used to it. But I'm not forcing you to use a table. I'm not giving you marks for the table. I'm giving you marks for, go back. Giving you marks for this calculation and then the answer. So that, actually just the answer. But if your answer is wrong, I can look at something and say, oh no, you didn't understand. It was just a little mistake. But if your answer is right, it's all good. But again, right, it's the first one that's this big. It takes time. But you'd be surprised. Not a lot of repetition. Did we do 1C? Yes, I guess so. We're on 2B. I don't remember doing 1C, but I guess we do. 548,456. Again, however you want to write something times, well, I need to decide what's the largest power of 60. I don't like it. I like the table. So I'm going to go power of 60 plus the table is going to help me later on. I don't know. If I had to generalize, the table helps most people. We can say how many groups or how many groups of that size, how many times does it fit in, whatever table headers you want to use. What have I used? And what is left? So what is the largest power of 60 now? Well, I know, I've learned, 60 cubed is 216,000. And that can fit. That can fit in. But the largest one, the one next, not that I know what it is, but it definitely won't. 60 cubed is 216,000. So it's definitely handy to remember these 3,600, 216,000. It's handy. And then once I pick a starting point, I have to go all the way down. And the ones. So how many times does 216,000 fit into my original number? 2 times. To give me 432. Which clearly does not leave me space for another one. So perhaps, while I'm thinking of this, perhaps, no, the used one is exactly that column. I thought maybe I will add a column to help, but used is exactly now 2 times 216,000, which would be 432,000. Then you do a subtraction to see what is left. 16 for 100. 4, 5, 6. And perhaps it seems a little fast when people are saying these answers and you're still typing it. It's okay. It's not a race to use a calculator. I think everyone would agree, hopefully, that the quiz was time-wise reasonable. No? No, not at all? Oh. Well, it was. Did you use the practice quizzes as actual pretend tests? Be honest. No, you didn't. You have to pretend that you're actually here writing the text. And that one, I understand, the first part is also there's a lot of variations in that general puzzle kind of question. So the test one the cake one might have stumped you completely, taking a lot of time, whereas the next one might not. So these are much more predictable. You're going to get a conversion. You're going to do this. You can literally practice it over and over and over. So it's much more predictable in the questions that you're going to get. The only difference is you don't know the exact number. So in that sense, you can definitely time how long this is taking you in a more accurate way than part 1 would have been. Anyway, now I'm fitting in 3600s. Into what's left. So I take 116,456 divided by 3600 and I get into what's left. I'm fitting 3600s. Fitting in means division. So I write 116456 onto Mr. Calculator. Or Miss Cal, I don't know. Wait, she's doing it. Hold on. Do you have that number?
Yeah.
Divided by 3600. What does it say?
32.
I don't care about the points. 32. And stuff left over, right? The decimal doesn't really tell me how much is left over, so it's pointless to.
So we don't round it?
I just take the number and drop the decimals. I don't round it. I guess I always round down, but don't think about rounding. So now I want to know, I've used 32 groups of 3600. How much is that? That means multiplication. So 32 times 3600. She hasn't done it yet. 30? It's hard to multitask. I had math courses where I could not follow him and take notes. It was impossible. So I had to choose, which one do I do? I could not do both. So I understand. We're using 32 groups of 3600. To find out how much that is, that's multiplication. So 32 times 3600. Remember, this video is also on the website. If over the weekend you need to just listen to the whole thing again. Can anyone confirm that? Okay. So now I've used almost all of what was left, but not all of it. What's left? What was left minus what I used Not the hardest one in this case, but sometimes you need a calculator. It's okay. So you take the 1/16. Oh, I was multitasking. It didn't work. Speaking something other than what I'm writing. What the 1/16? What was left minus what I've used. You just do it on your calculator. It's fine. We had 116,000 and something left. That's now all I care about. Of that, I've used 115,200. What's left? That means subtraction. I strongly believe in this table. It just takes time. It just takes time. The calculations are all the same. If you don't have a table, you'd need to do it in your head, and that's bad news.
So how did you know to start with 60 cubed though? Is it because there's extra?
You want to fit in the biggest one that can fit in. Always the biggest. Because if I didn't have this, none of this, right? And I tried to fit in 3600s. How many 3600s go in there? A lot more than 59. Which tells me that I missed the bigger one. So now we have left 1256, and I'm fitting in 60s. So 1256 divided by 60. Calculator says 20. 20 times 60 is 1200. Is what I've used, and then clearly 56 are left, which the ones will just take. Use them all, be done. So I've accounted for all of the 548,456 just in little pieces. So that means that now, you don't have to write this. It just helps in case you make a little mistake in the end. 2 groups of 60 cubed plus 32 groups of 60 squared plus 20 groups of 60 plus 56 left over. It's just because the numbers are bigger. So then I'm going to have to zoom out so I can see everything. That means I have a 4-place number. And I simply have to convert 2 to Babylonian. Space 32. Space 20. Space 56. Done. So the work that you show is really just in case you make a mistake here by accident, you have something to fall back on. You don't have to keep track of things in your head. The less you write down, the more you have to keep in your head. And that's tricky. I'm hesitant to ask how this is feeling, because it just takes time. Think of the first Roman number. You were not happy. But you feel so much better now. Still not? Better. Repetition helps. Repetition helps. If it helps, we're only doing these 2. Well, that's actually a lie. Only these main ones. Looking at that, any questions? Any questions? I don't choose Babylonian for no reason. It's a part of our daily life in small ways, but it is. You've used it in a little way today. Every day. You'll use it tomorrow. Babylonian numbers. Still some part of it we're using today. We still use Babylonian numbers today. Think about, let's go back to the previous example. Actually, no, let's not. If I ask you, convert 23,596 seconds into hours, minutes, and seconds. What would you do? How many seconds are in a minute? How many minutes are in an hour? It's Babylonians that made that. Think it was just random? You just decided to count in 60s? No, they did, and we stole it from them. Well, not stole, it just came down to us over the years. You would do exactly this calculation and say 6 hours, 33 minutes, 16 seconds. It's the same number. Because 23,596 is 6 times 60 squared. Well, 3,600. If there's 60 seconds in a minute, 60 minutes in an hour, it's 3,600 seconds in an hour. What was the other one here? I can't remember. 33 times 60. Where is my cursor? There it is. And what was the other one? 16. It is 6 hours, 33 minutes, and 16 seconds. Now, I'm not saying you convert a large amount of seconds into hours and minutes every day, but whenever you look at the time, it comes from the Babylonians. So it makes a little bit of sense to look at their system. It's not completely detached from what we have today, which is why I don't look at the other ones that have sort of died out, and we don't have any connection to them. Romans and Babylonians, we have still a little bit of a connection. So maybe that helps you keep yourself motivated as you practice these questions. We have one more. And I get the feeling we should probably stop after this one. But it could just be me. Is it just me? No reaction says it's not just me. You probably stopped listening already. And I may be talking to myself right this very second. What is the key to succeeding in any math course? Yes. Yeah, yes, but yeah, absolutely. But studying, what is the key to studying? You're right. Repetition. Over and over and over. If you practice 2 more examples instead versus someone of the same ability with fewer examples, you will do better. Guaranteed. There are studies that show it. Whereas that's not true in other subjects, right? I can write 2 more essays. That's not going to improve my essays at all. But in math, it's much more of a reliable technique. So I go powers of 60. Then this is the table that I decided on. It's not that you have to. How many, or how many groups, or how many times, whatever you want to write. As long as you know what you're doing. What have I used? If it helps your motivation, this is our last example for the day. What is left over? Now, knowing that that 60 cubed is 216,000, that's not going to fit. So I just need to start at 60 squared and then go all the way down. Because 216,000 is too big. It's too big. How many times does 3,600 fit into 159,000? 44. 3,600 times 44. 158,400. Now, you don't have to do it that fast, as long as you can do it. And it'll get faster the more you do it. Don't aim for speed in the beginning. What is left? Oh, not a lot. But I could still fit in some 60s. How many 60s can fit into 1052? 17. 60 times 17? And I only have a little 32 left. Yes, it totally should. Still only 32 left. And I have the ones, so that was the ugliest 3 I've ever written. The ones to mop it up. Which tells me how to split up this 159,000 into 44 groups of 60 squared, 17 groups of 60, 32 left. I can fit it in if I erase these lines a little bit. So I have a 3-place number, 44 converted. That's not the prettiest 10 in the middle there, I apologize. Space, 17. Space, 32. A little bit of practice goes a long way.